So ammonia came last year, crude oil came on the 2022 paper. So here is the crude oil question A. Crude oil, a complex mixture of naturally occurring hydrocarbons in a raw material that has many uses. Crude oil must be separated into various components and modified to be useful. Right? So the first thing we must do is complete the table. I'm assuming we can complete the table. Right? We can complete the table. So what are our responses there now? Alright, so let's get this over. The boiling range of the refinery gas, this is below 40 degrees Celsius. Right, gasoline is gonna be this is gonna be kerosene. Or is it kerosene or gasoline? Which one? The boiling range of 80 to 180. That would be that would be what? 5 to 10, that would be gasoline, right? 16 to 20 to 25. I am not sure. 16 to 25, what would 16 to 25 be? 16 to 25 would be diesel, right? Or those fuels like car fuels, etc., right? And this would be around 260 to 350, right? So I have something like that. The number of carbons for refinery gas would be 1 to 4, and that would be propane, butane, those type of things. And then we have the uses now. The uses for gasoline, right? Gasoline we did what for cars? So fuel, right? Generally there. Diesel would be known for what? This is for cars, and then this now would be fuel for what? Trucks and stuff like that. Truck engines, etc. Right? Residue now that would be around that would be greater than 350. Number of carbons would be greater than 25. Alright? And uses would be asphalt and bitumen. That's what we use it for. Alright? Define the term catalytic cracking. What's catalytic cracking? Catalytic cracking? Using a catalyst. Lovely. And what that catalyst tends to be what? What's the catalyst that we normally use? Do we remember? The catalyst is zeolite. Alright? Write the balance equation to show the products of the cracking of decane. And we know decane can be anything, so let's just do this the easiest one, right? So the balance equation we know is going to be C10 H22, and we have to produce any alkene we want and any alkane that makes sense, right? So let me just go H18 and give you a simple C2H4. Alright? This is gonna be decanes are liquid, octanes are liquid, ethenes are gas. Alright? So stuff like that. 2 marks. We just need to write a little cracking equation here. Alright? Explain the principles involved in fractional distillation of crude oil. Do we know the principles? What are the principles involved? Go ahead. Okay, lovely. So we have that. Hopefully everybody has that explanation, right? So longer chains at the bottom, right? Right? Lower viscosity at the top, higher viscosity at the bottom, stuff like that. We must be able to explain the principles. It is the heat gradient, the temperature gradient that they want to explain, right? And how does that affect the components? How does that affect the fractional distillation of crude oil? Explain how one adverse effect of the petroleum industry can impact the environment. Any, anyone. So we can talk about air pollution. We can talk about oil spills. Lovely. Oil spills. What else you can talk about? There are multiple things you can talk about, right? But just choose the easiest ones and just go after it, right? The one that comes closest to mind that you can explain a little bit more. How would that affect everything? How would the air pollution affect anything? You can speak about its contribution to the development of ozone in the troposphere. Speak about the production of photochemical acid rain, yes. Photochemical smog, right? Oil spills, think about the damage to wildlife, damage to the aquatic or marine ecosystems, right? Speak about those things, right? It's something that you guys must be able to do, all right? Define each of the following terms: reuse, recycle, and reduce. So, reusing, using items in their original form repeatedly. Recycling, processing waste material, right, into new products, right? And reducing, minimizing waste generation, right? So remember those things. So reusing is basically using items repeatedly in their original form. Recycling is processing waste into new products, and reducing is minimizing waste generation. All right. Speaking about those things, I don't think I need to go over them in depth, but if you want me to stop, you can stop me. Discuss how the concepts of reuse, recycle, and reduce can be applied practically to glass waste. So, how do we reuse glass waste? Right? In what way? How would we reuse them? Wait, that would be the recycle part. We're just talking about reusing. So, so we can use them. Go ahead. So I want them to repeat. Mm-hmm. The person was saying something. No, no. Okay. So reuse the glass bottles, so you can use them in different ways, right? So I don't know. This is a bit of a stretch. You can use it to make art. Ooh, wow, how beautiful, right? Or you can look at the returnable bottles specifically, right? So if you guys have beer bottles and stuff like that, a lot of persons would buy it back and refill it with the same products, etc. So the bottles can be reused multiple times, right? For the recycling part, the person was talking about the recycle. You can go. So the recycle, you color code the glasses. Then what would you do? So you sort the glass by color, right? Then you crush them, then melt them, and then after you melt them, you can use it to blow or recreate other glass products or bottles as well, right? So that would be the thing: the crushing, the melting, and the creation of new glass products, recycling glass there, right? And reducing as well, right? You could use lightweight bottles, right? You can use so glass bottles are not normally reuse. We tend to reuse like metal or plastic water bottles. You could think about stuff like that, right? Reusing those bottles, right, instead of purchasing and using glass products, right? So remember, um reducing is about minimizing the waste generation. right? So if you stop consuming high amounts of glass products, then you would reduce glass waste production, right? So you could think about stuff like that, all right? Describe the chemical processes involved in the production of chlorine and sodium hydroxide in the diaphragm cell, or when the diaphragm cell is used. Your answer must include the types of reactions taking place and the equations representing the chemical reactions, right? So this is now chloroalkali industry, right? So you must be able to speak about it, right? So with the chloroalkali industry, for this one, I drew a diagram. When I was doing this paper, I did draw a diagram. So I had something kind of like this. The diagram. Okay. So I wouldn't draw it on the lines. I would probably put it over in this region over here. But that is what I used to explain. So I wouldn't say it's not accepted. It is a way of using it's a way of explaining, right? So I would draw a diagram to let the person know exactly what I'm talking about. I would number it and I would use that to remember what I'm speaking about. I wouldn't necessarily refer to the diagram, right? Because they didn't ask for a diagram, but I use the diagram to remember the structure of how I want to write my response. Alright? So diagram, I know step one, I introduce brine, which is highly concentrated salt water. Right? That is going to be oxidized at the anode to produce chlorine gas. Right? So that's how I remember things through pictures, diagrams. Right? So we have stuff like that. So we have the chlorine gas being produced, leaving sodium ions. We know that the sodium ions can go unidirectionally through the diaphragm, meaning it's only one direction the ions can flow, right? So it goes through the asbestos diaphragm, right? And the sodium now will be where the cathode is, right? At the cathode, we're going to have the production of hydrogen gas, right? Leaving hydroxide in solution, right? And when we have a high concentration of sodium and hydroxide ions, we get the production of sodium hydroxide, right? And because the diaphragm is not it's not the membrane, right? Remember the membrane stops all sodium from entering, but the diaphragm allows some amount of sodium chloride to enter, right? So we're gonna end up with impure sodium hydroxide being produced, right? And you just have to remember how to write your equations. We know that we're gonna have the chloride, right, to produce what? Cl2 plus 2 electron or so, right? At the anode. And at the cathode we have what? H plus the electron gives us, sorry, 2 of each, right? To give us H2 no so. So you must remember the equation. This is the anode and this is the cathode. Alright, so that's what the question is calling us to do. It asks us to explain the process step by step, right? My favorite organizational strategy, right, is listing. So step one, get the reactant, right? Step two, what happens at the anode? Step three, the residue from the anode passes through the diaphragm rather. Step four, what happens at the cathode? Step five, sodium and hydroxide mix, right? Also note that sodium chloride can pass through the diaphragm. And step six, collection of impure sodium hydroxide. Just those things you need to state out, right? 5 marks for all of that. So I would use see all that big space at the bottom. I would just draw the diagram, number them, and I use that to follow through so I don't miss anything. Alright? So we could look at something like that. 100% on module 3. That's what we want. E. The chlorine production in the chloralkali industry may be reacted with the other products of the electrolysis, hydrogen and sodium hydroxide to produce two useful products. Describe the chemical changes which occur to produce hydrochloric acid. This is an interesting question. Hydrochloric acid production, isn't that just H2 plus Cl2 to give you 2HCl? Lovely. And for the hypochlorite, isn't that just Cl2 plus 2NaOH to give you NaOCl plus NaCl plus H2O? NaOCl is the hypochlorite, which is bleach, right? So looking at stuff like that, that's what you must do. Your chemistry must click, right? If you have a love for chemistry, you'll remember these things. That's off the dome, straight out of the brain, right? So these things must be clicking. Part 3, which is the last part of the 2022 paper, two modifications that could be made to the structure of the electrolytic cell to ensure that these chemical changes in E2 do not occur, right? So what we must do, right? In E2, what we see chlorine reacting with the sodium hydroxide. Go ahead. PTFE, polytetrafluoroethylene. That is a membrane in the membrane cell. Lovely. And it prevents any mixing. So it prevents mixing from the two chambers. I don't even mixing from the two chambers in the cell, right? What else we can note? What else could we note? We could adjust the pH to prevent hypochlorite formation. That's another thing we can do. We can adjust the pH there. Alright? But that is it. That is the end of the 2022 paper.